This FOA lecture covers cabling project management. By cabling, we're talking about being inclusive, fiber and copper cabling, and we're also going to include wireless. What we want to do in this lecture is to talk about what's involved in a cabling project and how the customer or the user of the cable plant and the contractor who does the installation work together to be successful in the installation of the cable plant. What's involved in a cabling project? Well, the project starts with planning. It then goes into the design phase, the installation phase, testing, and then operation. And what we want to cover in this lecture is what ensures success at each stage of this process. The cabling is important for your network. It's your communications connection. Cabling may be only a few percent of the budget for most communications managers, but it causes most of the problems. That's been true since IBM first started telling people that 40 years ago. In order to work properly, the cabling must be properly designed, installed, and tested by knowledgeable personnel. Once the cabling system is being used, the personnel who work with the network, particularly those who do the MACs, the moves, adds, and changes, must understand the cabling and how to work with it in order to protect your investment in your cable plant. What is the role of the cabling? Well, the cabling creates a communication system infrastructure that connects two or more points. It may involve standard systems or proprietary systems. It usually involves more than one medium: copper cabling, fiber cabling, and wireless. And it probably involves more than one type of protocol, although most networks are migrating to IP protocols. The cabling must meet specific standards and codes. By standards, we mean the specifications that determine how well it performs. And the codes are building codes that are appropriate to the area in which it is installed. And of course, all cabling must be designed to operate in a real-world environment. In order to be successful, a cabling project needs an understanding of the communication system needs and what is involved in that project. The contractor or installer must understand what the customer wants and/or needs and know how to provide that. And every successful cabling project needs a plan. It needs paperwork that describes the project so everyone can agree upon what is expected from all parties involved. All projects require attention to standards and codes. Standards are written by the industry to ensure interoperability of products. They specify the performance of the cable plant and the communication systems and generally require certification testing. Codes are written to ensure safety, generally fire and electrical safety, and are often legal requirements and may require inspections. Codes are different in various areas of the country, so you need to know what is the local code that applies to your project. And of course, the contractors doing the work and the users who will own the network must know both the standards and codes applicable to their project. Today, when somebody asks, do we use copper, fiber, or wireless? We usually answer yes, because you're probably going to use all three. If you need distance, bandwidth, and security, you're going to probably use fiber. If you need cheap cost, copper. If you need mobility, you'll use wireless. You need to know what kinds of devices you need to accommodate on your network in order to plan for the media that you will be using in that part of the network. And one of the things to think of is that there are new technologies like OLANs or optical LANs that are somewhat non-traditional but offer major savings in cost and energy. Are you willing to consider these alternatives? The first stage of every project is for the owner of the network, the end user, to define the project. You must define what kinds of communication systems are needed. Where will the system connect to and from? You need to create a scope of work, a preliminary document that will be developed over the entire course of the project to define what the finished project will include. It starts off as an overview but gets developed in great detail because it will lead to the request for proposals, requests for quotes, and contracts for installing the system. And along the way, you need to think about who will build that cabling system. The scope of work describes the work that will be performed in the installation, the goals of the projects, the tasks and methods to be used, the performance of the cabling plant, and how it should be tested. It will also include project timing, when to start, how soon it's expected to be completed. The scope of work may be part of a larger building document, so you may be working with architects and engineers on a building to develop the scope of work for the communications project. The scope of work must be clear, precise, and complete, and ready to be used as a primary reference for later documents in the project. The next step is to start picking your media. Copper, fiber, or wireless is appropriate for each section of the network. For copper, what kind of cables are you using? Most LANs use unshielded twisted pair, but other networks, like video or building management systems, may use other cabling types. What kind of fiber will you be using? Multi-mode or single mode? What kind of wireless networks? Wi-Fi, cellular, maybe something else. All of these need to be considered because the communications equipment will dictate where the cable plant will be installed and the types of media converters that will be needed. And now we're ready to start talking to potential suppliers. The next step is find a contractor. Typically, you evaluate contractors by their relevant experience, their appropriate certifications, like the FOA CFOT for fiber optics, their financial stability, and you always want to talk to references, other people they've done similar projects with, to find out how they work and how reliable they are. You want to get bids, but of course you always have to be wary of really low or really high bids, because that usually indicates something's wrong. You want to write a good contract, a fair contract, a contract that's easy for everybody to understand. And the other thing which you might need to do is ensure that you have contractors who can get along, because building contractors and cabling contractors and other contractors involved may have to work together. We use the scope of work as an overview, and the customer for the network and the contractor cooperate. They start doing layout drawings, showing where the cables will run. Then you want to physically walk or drive the routes of the cable and take pictures, because that will be the way you can refer back to what is going to be the route and special problems in installing the cable plant. You need to decide if you need building facilities to be constructed or modified. And when you have the basic layout designed, then you're ready to start choosing the components that you're going to use. The reason we said that you should physically walk or drive the route of the cable plant is it gives you an idea of what network reliability and restoration issues may be. What's the vulnerability of the cable routing, both indoors and out? Where is it likely to be damaged in the future, and how easy will it be to troubleshoot and repair? Does the design plan include excess cable and hardware for restoration? That's one of the things you need to plan from the beginning. You always buy extra components, store them away, along with drawings of the cable plant, so you'll have them available for troubleshooting and restoration when a problem arises. Next, we start choosing components. The communications equipment we will use, the cable types, and the cable plant hardware. All of this will be chosen based on our earlier designs. What communications we want to carry over what cable plant from what point to another. So we must look at each and every section of a cable plant, decide what components are appropriate, particularly if they have to be in an outside plant environment, and then we start talking to vendors and choosing components. Once the network is designed, we're ready to start thinking about installing it. And the first thing we want to consider is safety. Have you written safety procedures into your scope of work? Are personnel being trained in safety on the project? Does everyone have the proper safety equipment? And are supervisors observing all the procedures for safety? Nothing ruins a project faster than an injury accident, so safety should be first, last, and always. There are a number of things that will be going on simultaneously as we begin installing the network. We're going to be purchasing components and equipment. We're going to be preparing the facility, the area where the cable plant will be run, and we're going to get our personnel trained and tools prepared. This is a stage which requires continual coordination between the customer and the contractor. There must be designated persons responsible for working together on the project. The project can come to a screeching halt very fast if the contractor can't find the customer to talk to and the customer can't find the contractor. One of the issues we have to deal with in premises applications is abandoned cable, especially during network upgrades. Many buildings have tons, literally tons, of abandoned cable that needs to be removed in order to meet the requirements of the National Electric Code. Your contractor needs to understand where those cables are and how to remove them without damaging other cables in the building. The good news, however, is copper is expensive and all this cable can be recycled for a pretty good amount of money. One of the things to look out for when you're buying components is counterfeit cable, both fiber and copper. It's typically made you know where, and it's made to be cheap to manufacture, but often, interestingly enough, does not sell for cheap prices on the open market here in the States. We advise you to look very closely at the cable you're buying. Anything in a plain, unbranded box is suspect. We've seen Category 5 cable that's not copper, but is aluminum cable coated with copper. A lot of the cable jackets on both fiber and copper cables that are counterfeit are highly flammable and extremely dangerous. Make sure you know who you're buying your cable from and who manufactured it. The components from which the cable plant will be built are usually needed on the job site a little bit in advance of when the actual installation work begins. Unfortunately, all of these components are quite valuable, easy to steal, and easily resold on the web. We advise you lock up the components that you leave on the work site or provide guards when necessary so that you don't have to deal with the theft of the goods and purchasing more. Every cable plant installation project is different, all unique, so it's hard to give firm advice. But here's our overview. You locate and build the OSP cable facilities and hardware, install the cables, direct buried underground or aerial, using the proper techniques, terminate and splice the cables, test them to the proper requirements that you wrote into the scope of work, and document the results. We're going to talk about documentation again. Documentation begins at the design phase, but during the installation phase, it's very important to keep all the documentation up to date as the components are being installed. Premises cabling generally requires the installation of cable hardware, conduits, cable trays, and racks before you actually install the cable. You want to install the cables in what's known as a neat and workmanlike manner, like the NECA FOA 301 installation standard for fiber optics. You terminate the cables or splice them as needed and test them to the requirements that you put in your original scope of work. Again, document the results. Make sure that when everything is installed and tested, that there are documents that tell you what goes where and that it met these test requirements. The final step in installing the network is to test it and record all the test results in your documentation. For copper, you'll typically do certification testing to structured cabling standards. For fiber, during the design phase, you will create a loss budget to create the go, no-go, pass, fail criteria for testing insertion loss. For wireless, you'll look at coverage of the wireless signal over the area that is expected to be used. One of the things to do is only do the tests that are needed. We often find people calling for OTDR testing, for example, on short premises cabling, where it makes absolutely no sense at all, but adds tremendously to the cost of installation. If it doesn't need testing, don't do it. Let's talk about documentation. Documentation must start with the project concept. The documents must tell the customer what they must know about the cable plant and the communication network it supports. During the design phase, it'll include drawings. It'll include data on each cabling run, what component types like cables and connectors are used, what the length is of the cable runs, and once the installation is done and the cabling is tested, the documentation will include the test results. Documentation is the final proof of a proper installation and is generally required for completion of the contract. So the contractor doesn't get paid until the paperwork is done. Once the cable plant is installed, the next step is to install the communications hardware, turn it up, and verify its performance. Once everything is running the way it's supposed to, we'll give you one piece of advice. Leave it alone. Restrict access to the network cabling to those who know how to work with it to ensure that no damage occurs doing moves, adds, or changes. Most damage that occurs to cable plants, premises or outside plant, is caused by somebody getting too close to the cable plant who doesn't know what they're doing. Cabling requires no maintenance. Leave it alone. These pictures give you an idea of things you don't want to happen to your cable plant. You want it initially installed in a neat and workmanlike manner, and you want it marked so that hopefully outside plant cables don't get dug up by somebody else, and inside cable plants don't get messed up by people who don't know what they're doing, messing around with them. A lot of the problems you'll find are going to be caused by cables, and more than likely it's going to be caused by patch cords. One of the things that we've seen, we talked about counterfeit cable. Well, there's a lot of counterfeit patch cords. We've seen bins of different grades of cable in large big box retailers, and every cable had the same UL code on it, no matter what its grade or category rating. Be careful of mixing components. Mismatch category rated UTP cables or mismatch fiber cables can cause your network to go down. Whoever touches your network should have the knowledge and the equipment to troubleshoot problems. If you don't have that, make sure you have the phone number of a good contractor who can help you. So let's summarize. We start the project with a concept, we create a scope of work, and we begin our documentation. We interview and hire contractors with a contract that everybody understands. We design the cabling, we install it and test it, and we update the documentation at every step. Once it's installed, we don't abuse the cable plant. We plan for problems, and if we have to troubleshoot, we make sure that we have up-to-date documentation which will help us find the problem and fix it fast. Your cabling is important. It's the heart of your communication system. It may only represent a few percent of an IT budget, but it typically causes most of the problems. The cabling must be properly designed, installed, and tested by knowledgeable personnel for it to work properly. And the personnel who do anything with the cabling, like moves, adds, and changes, upgrades, anything, must understand the cabling to protect the investment. Your cabling is a big investment. Protect that investment. The FOA has lots more information on cabling on its website. You can go to the FOA website and find literally hundreds of pages of free technical information and free online self-study programs at FiberU. If you found this video on YouTube, you know we have about 80 or 90 videos on our channel, the FOA Inc. All of these are available free for you to use to educate yourself on what you need to know about copper, fiber, and wireless, the cabling that's the heart of your communication system.